Welcome to a lesson with Dr. Powell. Let's look at another example of partial fraction decomposition. Suppose that we have an integral like this. 1 over, and let's do x squared plus 1 multiplied by x minus 1. Okay, so let's think about how this integration would go, what we would do. Now, first of all, we're going to use an idea that if we have two factors that don't share any common factor at all, they actually came from adding, where you had this part and you had this part separately. And since the degree of this is less than the degree of the bottom, that means the degree of this part is less than the degree of its bottom here, and the degree of this is less than that, which means this better be a constant right here. Maybe we'll make that a, and this one, we can make it bx plus c, a generic linear term that has a degree less than this x squared here. Okay, so we have an equality here. This is equal to that. Now, we can start by plugging things in. In fact, sometimes it's nice to be able to to do as follows. I mean, if you multiply everything out by this denominator, look what happens, like this x squared plus 1 times x minus 1. If you multiply it to this side, let's just see what happens for a minute. X squared plus 1, x minus 1. So as it distributes to this factor, this term over here, x squared plus 1 cancels, you're left with bx plus c. Over here, the x minus 1s cancel, you're left with, let's see, times x minus 1, sorry, times x minus 1. Over here, the x minus 1s cancel, and you're left with a x squared plus 1. Okay, so we have this, and on this side, you just have that 1 there. Now try plugging in different things. If you were to plug in 1, for instance, this part would be 0. And then you would have 2a is equal to 1, which means a is equal to a half. If you plugged in, and we got that just by plugging in 1, because notice that made this whole part vanish. All right, now if we were to plug in, let's see, something else. I mean, technically speaking, you could plug in an I here, an imaginary number. It still works. It's still an equality, even with if you increase the domain to consider complex numbers, because I squared is -1. And so you'd have 0 over here, and then you have an I minus 1 bi. You can multiply that out and then equate imaginary and complex. And actually, you could probably get it right immediately right away, see exactly what it is. Might be kind of simple, actually, but nonetheless, you don't have to. You could just plug something else in, like, because you know what a is 1/2. Plug in 0. If you plug in 0, that's kind of nice because this b goes away. Plug in 0, you just have a c times -1, which would be a negative c. So actually, we're quite well off. And then 0 would be 1, 1 times a half. So plus a half is equal to 1. Subtract the half over. So then you have a half is equal to negative c, which means that c is equal to negative a half. Okay, so we know c is equal to negative a half. Now, actually, it might be, we might be able to get another thing just by using the other technique that we have seen in another video, which is to just multiply this polynomial out. In fact, let's just look at the x squared term. So we have an ax squared here, and then here, the x squared term is going to come from this bx times x, which is just bx squared. We're going to have other terms, but we're just concentrating on the x squared terms. It's these added together. And over here, you know, it's 0x squared. That tells me that a plus b is equal to 0. Well, if a plus b is 0, and a is a half, then b better be negative a half. And so we actually have all of them. Okay, so we have a is a half. So this part right here is a half. And then I know b and c are both negative a half. So maybe I could just put a half here and a half, and then make this whole fraction a negative. All right, and then kind of proceed as follows. In fact, I could even factor out a half out of the whole thing if I wanted to, um, and the whole thing. And then we would just simply have, um, so if we factor out a half, let's write it out, then we'd have negative a half multiplied, let's see, we have x squared plus 1. Here we have an x plus 1. Then over here we'd have just, okay, well, let's just, I guess I didn't factor out of the whole thing quite yet. Okay, now we can factor out the half out of the whole thing, but leaving this negative over here, applying to that whole fraction. Maybe I'll just distribute the negative into the numerator, that's fine. Okay, back into it. All right, and then we have plus, and then the half is factored out. So we have something like this. Okay, then we could perhaps integrate this thing, which can be done in a number of different ways. This part right here, the antiderivative, is a natural log of absolute value of x minus 1. Here, this one, I would split it up to something like this: negative x over x squared plus 1, and then might do a minus 1 over x squared plus 1. This guy right here, use a trig substitution, or just know that this is the derivative of inverse tangent, and so the antiderivative is just negative inverse tangent. This part right here, you could use a u substitution, with u being x squared plus 1, because the derivative is 2x, and you'd have x's canceling out. So you could use a u substitution there. Here, you could use a trig substitution. Here, you could do a natural log of absolute value of x minus 1. Won't work through the details. I'll end this video at this point, but nonetheless, we can kind of see an instance of how we could make this work. Thanks for watching.